Okay, for number one, it says find the sum of the roots. This is a trigonometric equation, it's tangents, and they want the roots only between 0 and 2 pi. All right, so let's go to the whiteboard, and I'll go through my strategy for doing the problem. It may differ from other people, though. So this is number one. So I know that there's a tangent, it's being squared. There's some angle x between 0 and 2 pi, by the way, inclusive. Minus 9, tangent of x plus 1 equals 0. And the answers are going to be only on the interval between 0 and 2 pi. All right, the first thing I would do is rewrite it in terms of more familiar functions. So I'm going to go towards sines and cosines. So the first term would be sine squared over cosine squared. The second term is going to be sine x over cosine of x plus 1 equals 0. The next thing I'll do is I'd clear the fraction by multiplying both sides by cosine squared. All right, so I'm going to multiply both sides by cosine squared. Now, before I do that, I want to point out that cosine squared can't be equal to 0. When would it be equal to 0? Well, I want to just do a little tiny graph over here before I do it. And there's two places where equals 0 between 0 and 2 pi. That would be pi over 2 and 3 pi over 2. Well, what I know about the original equation, these numbers are not allowed in the original equation, so I'm not worried about that. So let's just multiply it then. You get sine squared minus 9. One of the factors, and again, multiplying by cosine squared, would cancel off. I get cosine x. Then I get plus 1. No, not plus 1. Plus cosine squared, right? And 0 times cosine squared is just cosine squared. Now, certainly, I notice immediately I got a Pythagorean identity, because sine squared plus cosine squared is 1. So I have 1 minus 9 sine x cosine x is equal to 0. All right, now that might seem problematic to you, but it's not that problematic. I'm going to, get this to look like something I can solve. So really what I'm doing, I'm going to try to solve for sine x, cosine x, and what I do is I subtract 1 from both sides and divide by 9, and I would get 1/9. All right, so I got troubles over here, and someone says, what are the troubles? I got two different functions, sine and cosine, and I'm starting to realize this might be related to a double angle formula. For example, the sine of 2x is equal to 2 sine x cosine x. So I'm going to multiply both sides by 2 now. You get 2 sine x cosine x equals 2/9. So the left side's easier for me to deal with now. What is it going to be? It's just simply the sine of twice the angle x. And that's equal to 2/9 now. Now granted, this is not a nice number, but what I'm starting to realize is that I can figure this thing out. And the reason if I look at the sine function, the sine function looks like this over here. This is the number 1, and 2/9 is going to hit it twice. So I'm going to write the reference angle down. So 2x, right? The reference would be the arc sine. You know what, I need more room. I'm going to get an eraser out. I'll erase this business over here. I need more room. Or write smaller, whatever. So I'm going to say 2x, I'm going to do the first quadrant, by the way, is equal to the arc sine of 2/9. But it does repeat itself. And how often? Every 2 pi k. All right? So that's this one here. Now I want to do this one over here, which is in the second quadrant. So what would 2x equal then? I'm going to be careful about this. In the second quadrant, it's actually going to be pi minus the reference, which is arc sine of 2/9 plus 2 pi k. All right, kind of complicated, isn't it? So what I'm going to do is I'm going to divide through by 2, because I want to find out what x is. So x is going to be equal to, that's going to be 1/2 arc sine of 2/9 plus pi k. I want to point out that x is some number between 0 and 2 pi. All right, so I'm going to start writing down the solutions now. So x could be equal to, I could take k to be 0, by the way. You get 1/2 arc sine of 2/9. You could also get another one, and it's going to be 1/2 arc sine 2/9 plus pi. But I can't go to 2 pi. All right, let's put the next one down. So I got two answers there. The next one's going to be x equals pi minus arc sine. By the way, arc sine of 2/9 is an acute angle between 0 and pi over 2. And then it's plus, I'm dividing by 2. Oops, I forgot to do that. Plus pi k. All right, I took the second equation here and divided it by 2, just like I did the first equation by 2. So I'm going to write the answers down for that. And what do you get there? X equals pi over 2 minus 1/2 arc sine of 2/9. And I'm getting the k to be 0, so that's 1. Let's put the other one down, pi over 2 minus 1/2 arc sine 2/9, and then what are you going to get? Plus a pi. All right. So what am I going to do here? I'm going to look at it, and I got to be careful now, don't I? I have 4 separate answers. I'm going to highlight those for you. I have this answer. I have this answer. I have this answer, and I have this answer over here. Now someone says, what did they ask for? I'm going to go back and read the question. It says, find the sum of the roots. All right, now the sum of the roots, I can call it S. I got to take these things and add them together. Well, let me just count on that, the arc sine business here. And what am I seeing? I'm seeing, the arc sine of 2/9 there. It's half of it, half there. But then I'm seeing minus half here, minus half there. So all the arc sines disappear. So what I'm going to do now is just write down what's remaining. What's remaining? I do see pi. That's right here. I see pi over 2. There. I see pi over 2 here. And I see a pi over here. Can I add those together? I think so. You get pi. Pi over 2 plus pi over 2 is pi. You get another pi. You get 3 pi's. And we're done. Thank you.